Okay, so this is, by my count, the 15th YouTube video review problem. Plus, we did the 4 problems for the quizzes, so we've gone over 19 problems to review for the final. Hopefully, it helps you out. Okay, so here's the last problem, and let's read this. So you've got this spool, it's spinning around those rollers A and B. You're pulling that force, and it says that 8 meters of the cable unwinds. There's no friction. Find, let's see, find, what is it asking us to find? Oh, here it is. Determine the angular velocity. Okay, so you have forces times distance, and you have velocities. Definitely a work energy problem. Okay, so we're going to do this. Everything's going to be spinning around O. So the initial kinetic energy says start from rest, 1/2 I omega squared is 0. Afterwards, it'll be spinning, so it'll have 1/2 I omega squared, and that's what we're trying to figure out. Okay, and so we want to find the total work done. Okay, so it's forces times distance and moments times angles. Okay, so that 400 Newton force, it says, is going to unspool 8 meters of cable, so that means it moves over 8 meters, so the work is 400 times 8. So the next question is, what kind of work do the weight and the normal forces do from those rollers? And well, they're not moving, so they're not doing work due to moving, but are they adding moments and doing work by moments? And so here's a free body diagram of the weight and the normals. I've not drawn in the P. And so because those are rollers, they're going to have a reaction normal to the wheel. It says neglect friction in the rollers, in the mass of the rollers. And so those reactions are all going to the middle through the pivot point, so they have no moment, so there's no work due to moment. So in the end, you just have 400 times 8 equals 1/2 I omega squared. They give you the radius of gyration, k sub g, and so the moment of inertia is the mass times kg squared, and you can easily solve for omega 2. Okay, so hopefully these videos will help, and you'll all do well on the finals, and I'll see you either Wednesday evening or Friday morning.